Hi guys, today is a good day to switch over from my wet cell batteries over to AGMs. I'm going to shut my system down in a controlled fashion and then bring it up one piece at a time. So first thing I'm going to do is disconnect the solar array. So now all the panels are disconnected and I have no charging going on. I'm going to disconnect all the DC loads and disconnect the inverters. That's a low voltage alarm. And I'm going to take the loads that were on the inverter and hook them up to grid power. Currently, all of my wet cell batteries live outside. They're in a weatherproof box. That way I avoid any off-gassing issues inside the garage. The AGM batteries now live underneath this bench. You'll see that in a minute. The bench is on wheels. The cart that the batteries are on is also on wheels. Each of these batteries is 12 volts. They're rated at 200 amp hours each. So I have 1,000 amp hours of battery available. One nice thing about AGM batteries is their low internal resistance. These things can supply up to, I think it's 1,400 amps for 5 seconds each. So if I put on a very heavy load, the voltage won't suddenly dip going to the inverter, causing it to shut down because of a low voltage issue. Right now I'm working between rain showers. We have Tropical Storm Alberto paying us a little visit. So on each of my batteries, I'm using these Anderson 175 amp quick disconnects. This gives me the ability, if I have one bad battery, I can isolate it by simply unplugging it. These were 6 volt batteries, so I would take 2, put them in series to make 12 volts, and put 4 sets in parallel, and that gave me a roughly 800 amp hour battery bank. That's it. That's all 4 disconnected. And what I'm going to end up doing is disconnecting from the bus bars inside and pulling the cables through. This is a temperature sensor setup that I made for my batteries. So each battery's got a separate temperature sensor. It's all hooked to an Arduino project. If any of the batteries goes over 120 degrees, it would set off an alarm. Usually that's an indication that I have a cell that's shorted out, and the battery will start off-gassing after that. I had that happen years ago when I had a battery bank inside my garage, which is why I don't put wet cells in the garage anymore. Okay, that's everything disconnected here. Disconnect the camera for a moment so you can see the harness. There's I think that's a 3-inch PVC duct down here. And that actually goes through the wall. It goes into the house, and I have these 2-gauge wires actually fished up to my bus bars that way. So I'm going to disconnect all these, pull them through, and then reroute these to the wall inside and have them come out above the AGMs. I was trying to figure out what all that beeping was. It's my garage door opener. It's got a battery backup. When the power goes off, it starts to squawk. Well, it's normally plugged into my solar setup, so it never goes without power. But I just shut it all down. Okay, I'm gonna get a driver and I'll get that out of there. I'll put a piece of Lexan across here just in case anything got dropped. It can't bridge across and create a massive spark. So you can see all the batteries are all using this 2-gauge heavy wire. They all share the load. The 2 inverters I have are actually using this massive 4/0 cable, and that's what is required to run 200 amps into the inverter. You see all the battery cables go through here, they come out down there. There's a hole down below that I'm going to pull each of these out. These are all 1/4 stainless hardware. Let's see if I have a 7/16 driver, and I do. Okay, hopefully that'll start pulling through. Oh, hopefully they'll all go now. Okay, the last thing I need to do out here is disconnect all of the Anderson cables. Go ahead and put the cover back on before the monsoon kicks in again. Okay, here's some of the tools I'm going to be using. This is a Klein cable cutter. You can cut this heavy cable and the big 4/0 stuff with a hammer and a chisel, but this is way easier. It's got a ratchet. It just shears the cable off nice and clean. If you're only doing one or two, not worth buying, but if you're doing a whole bunch, sure is nice. I'll use a meter to check everything. The Anderson quick disconnects that I'm using are rated at 175 amps. So I bought fuses to match 175 amp. The short amount of welding cable that I use, it's all 2 gauge, and I'm going to try and keep the cable lengths down to 6 or 7 foot, and that'll be below the 3% drop off, I believe. To crimp the big Anderson connector pins, these big things, I'm using an anvil style crimper. Essentially put your conductor in there, slide it in here, smash with a mallet. I don't have my big mallet with me, I left it at work, but that'll do. And I do it in 2 spots. It makes a different sound when it's done crimping. It has almost a ring sound where you can't compress it anymore. And my backup power, my backup charger for weather like today where it's cloudy and rainy. I have a Iota 75 amp charger. It was intended for 12 volt wet cell batteries, but Iota has come out with these little modules that you can plug in and it changes the performance of the charger. This one is actually designed for AGM batteries. It was about 30 bucks. Sure beats buying a whole new charger. I already have some of these pigtails made up to go on the batteries. The cables were different lengths on some of these because of the way the batteries are configured, just to keep things as short as possible. I tried cutting all the cables total length the same on all sets of batteries so they're drawing the same amount of current. And that's what I'm going to do again with this new setup. So I'm going to find out what the longest one needs to be and then cut all of them to match. And I'm going to have to fish each of these up. Let me get a ballpark idea, see what kind of length I need. So I might take about a foot off of these, but I'll leave the rest. I like having a little bit of extra play in case I ever have to re-terminate anything because of corrosion. Don't know what's worse, the rain or the heat. Okay, so I'm going to mark these, take off roughly a foot. And I'm going to do it to where the end of the wire is, just so I can be consistent. End of the conductor, I should say. Nice clean cut. So on my old setup I used 200 amp fuses. It's probably a little big. So I'm going to 175 amp. And I'll put this on the wire wheel and clean this up. Okay, so I get it in position. Just going to give it a love tap. I don't know if you can tell the difference in the sound. Can't pull that out of there. This goes on the negative side. Just pushes in and locks. And it's far enough up inside, there's no concern of a little bit of conductor hanging out. Actually, in the aerospace field, anytime we do a crimp, the amount hanging out should be the same width as a conductor. I've been a technician out at the Space Center since '92. Started working out there in '84. Changed jobs a couple times. Now at work, I've got the advantage of a 10-ton hydraulic press, and I can actually just put this in the press and crimp these in a controlled fashion. It's I won't say it's any easier to do than this, but it's a little more controlled. When I first started hitting this, if you don't hit it squarely, it's going to shoot out. So make sure it's sitting level and try to hit it dead square on the top, otherwise it might shoot out. That's it. That's all that goes on the batteries. I really like the style of compression connectors made by Thomas Betts. You can buy them at Home Depot. They make them in different sizes. These actually fit from size 8 to size 2. This is 2-gauge wire, so it's ideal. Take off about 1.5 inches. Do it. Now, I want that same amount here, so what I'm going to do is I'm going to cut it there and then take that insulation off. And what I want to make sure is that this top piece is not over the insulation, but actually right on the conductor. That's going to compress down just fine. If you read what the torque value is for these screws, it's a lot higher than I would have expected. So in the past I was actually using a torque wrench on these, but now I just give it a pretty good turn. Okay, so now obviously this one is shorter. Now when I put them together, I get pretty close to the same. And the foot length gives me enough room to go between the two terminals on opposite sides of the battery. So I just have to make up 4 more just like that. My temperature sensor setup has individual battery numbers, so I've labeled them 1 through 5 going from left to right. And I'm also labeling up each of the connectors, so if I still need to isolate something, it's real easy to identify which one I'm working with. It's a little different than what I'm used to. Instead of having a battery post, these have actually got metric bolts. And this wrench will actually go across there, so I'm going to have to find something different in the future. And that just does fit. I was a little concerned about that. AGM batteries run at a slightly higher voltage. All of these, after shipment when they arrived, were right at 12.9 volts. And the charge curve's a little bit different too, which is why I got the AGM module for the IOTA charger. And these are really intended to use a 14 millimeter metric wrench, but as I've discovered, a 9/16 is close enough. And the terminals on the battery are 1/2 inch, or on the Blue Sea fuse. And all of these fasteners are using a lock washer. You can get some thermal cycling with these batteries if you're running high current. So I prefer to use a lock washer and then periodically check them. Since these don't off-gas, I don't have to worry about corrosion anymore. Okay, so this covers up the connection that goes directly to this. So if you were to touch that to ground, that would spark with no protection. Same thing here, but if you touch here, you're actually going through the fuse block. So that's what each one's going to look like. So I have to do that 4 more times. Okay, I'm going to fish each of these 9-foot cables up through the wall. I've got a piece of parachute cord attached. I've got another piece attached so I can pull it back down through, and this end is actually tied off up here. That's about as far as I need to go. This is my 5th battery. So this is the one that's going to travel the most. One, two, three, four, five. And I'm just going to run them in. I will tighten them with the wrench manually rather than risk damaging something. Okay, I have all 5 batteries wired. I went through and tightened up all my connections on here. I'm going to go ahead and turn on the charger or the solar panels. So I'm turning on all the arrays. I'm only getting about 4 amps of charging right now because it's overcast. I'm going to go ahead and turn the inverter back on. And I got 119 volts coming out of the inverter, so it's happy. I did change the setting on my charge controllers over to sealed. It changes the charging characteristics, particularly the equalization. On wet cell batteries you can get stratification in the fluid, so you want to gently boil the batteries, bubble them, so that the solution mixes nicely. Well, in a gel cell or a sealed battery, where it's actually got a mat with the electrolyte in it, you definitely do not want to do that because you can damage the mat. So that's taken care of. I have added an AGM module for my IOTA charger. I left the original one here for doing standard wet cell batteries in case I need to charge my camper, which is on the other side of this wall. Since I won't be getting much sunlight today, I'll go ahead and turn on my IOTA charger, and that will go ahead and charge up my batteries overnight. And it's telling me it's putting in about 21 amps right now. That is separate than the solar. The solar is putting in 3 amps, so combined right now 20 amps roughly. During full sunlight I can get 50 out of solar, 75 out of the IOTA, so 125 amps going in. Since I am using bus bars, I can use much smaller cable going to the batteries. Each battery is tied in individually, so they share the load at the bus bar. I really like doing this method. Each of the cables only needs to be a much smaller gauge, so I'm using 2 gauge wire. If I was using one conductor going down and daisy chaining between all of these, it'd have to be something pretty massive because that inverter alone can draw over 200 amps. With 5 batteries and 5 individual sets of cables, that's only 40 amps per cable. So I'm more than covered. It also gives me the equivalent of 5 times the 2 gauge cable. So the conductor is about as big around as my pinky. 5 of them would be something roughly like that. And Anyway, this is a better way to do it in my opinion. It's the way some of the bigger, more professional telecom batteries are set up. This is the way we've done it where I work, so I've just copied the same thing. But if you want to do that, I'll leave a description or leave a link in the description of how I built the bus bars and where to get all the parts. So everything is up and running, and another project finished. Thanks for watching.